system. I just realized that I did not record this part. I'm so sorry. I just stopped it and I forgot to start it again. So I did not record this piece, and when I was asking you how to find fx and fy, I'm so sorry. So I can say it again. This prime is 4y, this prime is negative 3x squared, and this prime with respect to x is 0. And then fy, so this prime with respect to y is 4x, this prime with respect to y is 0, and this prime with respect to y is negative 4y. Okay, I think we got caught up. Perfect. You told me that I have to set these two equal to 0. Perfect. Now, in order to solve this system, look carefully which of these two equations should be addressed first. Which one is the easiest?
Probably the bottom function.
Yes. So notice that if I move this to the other side, I really get x equals y, which is awesome. It's an easy situation, right? So all I have to do is just replace here. Either x or y, it doesn't matter. So x equals y, why don't I go back here and say 4x minus 3x squared equals 0. And this is easy to solve. So in this particular case, we basically use substitution. We notice that the second equation, if we move 4y to the other side and divide both sides by 4, we get x equals y.
Excuse me?
Yes.
I just wanted to point out before we got further on, but I think it's 4y minus 3x squared equals 0.
Yes. So I replaced y
by
x.
Oh, okay, that makes sense.
Please always tell me, because you may see something. It doesn't matter.
Yeah,
even if you're wrong, it's okay. I'd rather go back and check if there is an error. We don't want to wait. Okay, thank you. So I use substitution because x equals y. I went back to the first equation and I replaced y with x. Or you can say, no, I don't want to do that. I want to replace x with y. Fine. And then you will have 4y minus 3y squared, which is the same thing. Doesn't matter. So now let's solve this equation. So we have, I'll multiply both sides by -1, 3x squared minus 4. It's because you know me, I always have to have everything in descending order. We will factor out the common factor. What is the common factor here?
X.
Very good. And we have 3x minus 4 in parentheses. And there are two possible options. It's quadratic, right? We expect two solutions. So what are the possibilities for x?
X equals 0.
Yes. Or 4 over 3. We move 4 to the other side and we get 4/3. Perfect. Okay, now let's find the y. But they are the same. So what would be the ordered pair that we have to discuss here? And what would be the ordered pair that we have to discuss here? Because the system...
0, 0, and then 4 over 3 and 4 over 3.
Very good. So this particular system has two solutions. Perfect. That was step 2. Now in step 3, we're not at the d-test yet. What is the next step? What do I need to determine or calculate now?
fxy and fyx.
Yes, fxx, fyy, and fxy, because they are in the d-test. If I don't have these three, I cannot determine. In step 4, I cannot find d. Awesome. So fxx, I go back here and I differentiate with respect to x. This will be with respect to x.
0.
Yes, and this with respect to x will be
6x.
Negative 6x. Please don't forget the symbols in front. Perfect. Fyy. I go back to fy, and now I differentiate this with respect to y. This with respect to y is
-4.
Yes, and all that is -4. Perfect. Perfect. Okay, and now I want fxy. I go back to fx, and I differentiate this with respect to y. Just 4. Perfect. What is going on here? Okay, 4. Perfect. So now I will calculate D for 0, 0. And later on, I will calculate D for 4/3, 4/3. So D for 0, 0. I have to evaluate fxx at 0, 0. What do I get?
Zero.
0. It doesn't matter what the other one is because it's going to be 0, right? I mean, even if I have whatever, 0 times this will be 0. So move on to minus. I have fxy, which is 4. Even if I want to plug in something, there is nothing to plug in, so it's 4 squared. So the answer is negative 16. So we know we have the following options: D greater than 0, D equals, less than 0, the order is not important, and D equals 0. And these will not give max min. So this situation for, let me put 0, 0 so we know it's the 0, 0. We got negative 16, which is this situation, none. So 0, 0 is not a point of extrema. It's not max and it's not min. Now we are moving on to 4/3, 4/3. See what happens with that. So D for 4/3, 4/3. Now, I have to plug in here 4/3. So 6 divided by 3 is 2. 2 times 4 is 8. So this is negative 8 times. Fyy I cannot plug in. It's fixed, negative 4, minus 4 squared. So this product is positive 32. This is minus 16. I don't care what the number is. It doesn't matter. I only need to know whether it's positive, negative, or 0. It is positive, and this quantity is negative. So what will you say about 4/3, 4/3? What does it give? So D is positive, and fxx is negative.
It's a maximum?
Yes, it's a relative max. Perfect. What is the relative max? I don't know. I have to plug it in. So it is f of 4/3, 4/3. So I have 4 times 4/3 times 4/3 minus 4/3 to the third minus 2 times 4/3 squared. So I'll share my screen. I'll put this in and see what we get. So 4 times 4 times 4, that's 64. And divided by 9, and then minus 4. I can put it in as 64 divided by 81. Divided by 27, actually, sorry. 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. And then minus 2 times 16 and divided by 9. And I get this. I can change it into a fraction. And it's 32 over 27. And this is the relative maximum. Is the relative max. This is the point that gives the relative max, but the actual relative max is this, 32 over 27. Very good pick. It was a good problem. Let's take a look. Do we want to look at another, or we want to jump directly to a word problem?
Can we go over another problem?
Yes,
13.
please choose.
Can I do 13 or 14?
Yes, you choose.
13.
13. So let's look at 13. Where is it? fxy, fx comma y equals. Make sure I copy the correct one. So it's e to x squared minus 2x plus y squared minus 4y and plus 2. I'm checking again. X squared, yes. Plus 2x, yes. Plus y squared, yes. Minus 4y plus 2. Perfect. Good. So we're asked to find max min. Awesome. Perfect pick. So we start with number 1. What do we do? What is number 1 all about?
Find fx and fy.
Very good. Fx, so let's do that. So e to a function prime. How do we differentiate e to a function and then prime?
It stays the same.
So it's e to that, but then times the inner function prime with respect to x only. So that's the idea. So e to a function prime is e to that function. I'm going to copy it, but times the inner function prime differentiated with respect to x only. So x squared minus 2x plus y squared minus 4y plus 2 times this with respect to x.
X.
Good. This with respect to x.
Minus 2.
Good. This with respect to x, this with respect to x, this with respect to x.
0.
Excellent. Everyone with me? Fy. How do I differentiate a function? E to a function. It's e to that times the inner function prime, but now differentiated with respect to y. This with respect to y.
Zero.
This, thank you. This with respect to y.
Zero.
This with respect to y.
2y.
This with respect to y.
-4.
And this with respect to y. Who cares? It's a constant.
Wait, would it be 2y, not 2x?
I did write x, thank you. This with respect to y is 2y. This with respect to y is -4. Thank you, thank you, thank you, thank you. I would have been in big trouble on the next page. Thank you. Perfect. Page 5. Good. Step 2. What do we do?
Set them equal to 0.
Yes. And create a system with e to that 2x minus 2 equals 0. E to that times 2y minus 4 equals 0. This is never 0. So for this quantity, because it's an e to a function, it doesn't matter. As we know, e either looks like this, never 0, or it looks like this if it's decreasing and it's never 0. So this is never 0. You can divide both sides by it. Only because this is 0. Otherwise, I can discard that. But this product to be 0 requires this to be 0. This product to be 0 requires this to be 0 because this is a number that is never 0. So then from here we have that x equals, and we have from here that y equals, and we determine the point.
One and two.
1 and 2. In step 3, what do we do in step 3?
fxx, fyy, fxy.
Excellent. Now, this is not a friendly situation. Why? Because I have a product. So I have to use the product rule. So we'll see. It could be easy because we are differentiating only with one variable. So we'll see in a moment. But we have to apply the product rule. First function, second function. So we are differentiating this expression, this product, with respect to x. This prime right, this to a function prime, I have to copy it and then multiply by the inner function prime. So e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime, which is 2x minus 2, times 2x minus 2, which is 2x minus 2 squared. So the first function prime times the second one, but now plus, I'm going to erase this because I don't have enough room, plus this times this prime. So it's e to x squared minus 2x plus y squared minus 4y and plus 2. And how much is this prime with respect to x?
2.
That's it. So these have to go from there because I don't have enough room. And this, I think, is, see, I go through tons. No, I'm kidding. But what will I do if one day they run out of whiteout? I'll be in trouble. I have to find something else. Okay, so then FYY. Same thing. A product. I have to use the product rule, 1 and 2. The first function prime, it's e to this times the inner function with respect to y, which will be this. So the same pattern. So e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime times this will be 2y minus 4 squared plus this, leave that alone, times this one prime. But this one prime is 2, so I'm going to put it in front. Okay, finally we want fxy. So this is, luckily, this is a constant. This does not depend on y. So I'm not using the product rule now. So this is a constant. It does not depend on y. So I will keep it in front. But I will differentiate this with respect to y. So this will be e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function with prime with respect to y, which is 2y minus 4. Okay, this was the most difficult part because we had to be very careful. We had to be very careful how we differentiate this. Okay, in step number 4, this is easy. So we have to evaluate these for 1, 2. So fxx, I have it here. I have to plug in 1 for x everywhere and 2 for y everywhere. So maybe I spoke too soon that that's easy. It's easy because we have to plug in, but we have to be careful. Okay, so I'll come back to that. So we want to evaluate fxx at 1, 2. E. Follow me so I don't make an error here. 1 squared, 1. Minus 2 times 1. Plus y squared. Plus 4, minus 4y, minus 8, plus 2. Okay, times. Nice. That's all gone. Plus 2. E. Again, this is all the same. So it will be 4. So this is 6. Okay, 2 and negative 2 will go away. So this is 5 minus 8 is negative 3. So let me try this again. So this was indeed, just to make sure, this is 1 squared. This is minus 2. This is plus 4. That's correct. This is minus 8. That's correct. And this is plus 2. Negative 2 with 2 go away. And this is 5. 5 minus 8 is negative 3. So this is indeed 2 over e to the third. Okay, we want now fyy evaluated 1, 2. Luckily, this is 0 also, so I'm not going to even put it in. So the first part, because whatever this is, times 2 times 2, 2 minus 4 minus 4 is 0. So it's just this one, which is the same, isn't it? Because it's the same calculation. Okay, so this is also 2 over e to the third. Okay, finally, we want to evaluate fxy at 1, 2. Okay, so this is all 0. Nice. Okay, so keeping that in mind, so here's our d. 2 over e to the third times 2 over e to the third minus 0. So this is indeed a positive number. We don't care what positive number. And this is fxx. So fxx at 1, 2 is positive. So the d is positive and fxx at 1, 2 is positive. So what do we conclude about the point 1, 2? What does it give? We did not determine it, but what does the point give?
Minimum.
Yes. And now the question is, what is that minimum? I have no clue. I have to go back to the original function and plug in. And when we plug this in here, we got -3. So it's e to -3 because we already calculated that. So f of 1, 2, we got e to -3, which is 1 over e to the third. And this is the actual relative minimum. So the point is 1, 2. The actual relative minimum is 1 over e to the third.